This week we're going to take a look at two sections, one in chapter 3, one in chapter 4. So we're going to be skipping around. We're not going to do every section in chapter 3. In fact, I think this is one of the only sections that we really do. Okay, so last week we learned how to take an angle, plug it into a trig function, and get an answer. Like a problem like this. So that could have been a problem you would have seen on the test. I gave you an angle, 45 degrees, gave you a trig function, sine, and now you tell me what the sine of 45 degrees is. So the way we did it last week is step 1, you had to find the coordinate. And then the second step was to plug that coordinate into a formula. You had 6 formulas. One for sine, cosine, tangent, secant, cosecant, cotangent. This week, we're going to use a chart to be able to figure those out, right? So you're not gonna have to memorize the coordinates or anything like that again. So anytime that we do something in math, there's always a way to undo what you just did. Right? Like if you added something to a number, what's the operation that's the opposite of adding? Yeah. Subtract. If you take a number and you find the square root of it, what's the reverse of that? Square. Right? So there's always a way to go back, and that's what we're going to learn for something like this. Let's say you took the cosine of pi divided by 4. You get 0.707. So the question is now, how could you take 0.707 and go back to pi over 4? Right? And that's what inverse trig is for. So I'm going to show you how to use the table to do some inverse trig, and then tomorrow I'm going to show you how to do it on the calculator. The first thing is we got to just kind of learn what's the symbols that they use when they write inverse trig, whether it's inverse sine, inverse cosine, or inverse tangent. So there's actually 2 symbols. The first one is the one that you usually see on the calculator. It's a sine with a -1 up higher. And if you do it on the calculator, it looks something like that. Sine with a -1 up higher. Now, there is another way to write inverse sine. And you can write what's called arc sine. Sine to the -1 or arc sine. It means exactly the same thing. It's just a different way of writing it. But for most things that I write, you're going to see sine to the -1. If you look at an older textbook, you may see the words arc sine. And it's exactly the same for inverse cosine and inverse tangent. And when you're dealing with the inverse, it just puts a little -1 up higher. Now, that -1 is not an exponent. It's not an exponent. And I can easily prove that to you because if I type in something like that, and then I type in something like sine 0.5 to the -1. Okay. So in the first one, I put what's called inverse sine. In the second one, I have a -1, but it's in a different spot, and they're not the same thing. So raising it to the -1 power is not the same thing as inverse sine. I just want you to see that they're different. What can make that a little confusing is if that number right here is anything except a -1. -1 is special. But if it's anything except the -1, it is a power. Right? It is an exponent. So like if you put something like this right there, put a 2, that does mean take sine and raise it to the second power. But this does not mean take sine and raise it to the -1 power. So the -1, it's just kind of a special symbol that means inverse. That's all it is. Don't think of it as an exponent, even though it is higher. So, whenever you do inverse trig, you're going to notice that your answer that you get, it always stays between certain numbers. Right? Like, you saw what, let me just do a couple of them. Second inverse sine of, let's do it in degrees, because that'll just make it easier for you to see. Inverse sine of 0.5. I get 30. Inverse sine of 0.8. I get 53. Let's go inverse sine of 0.9. I get 64. Inverse sine of 0.999. 87.43 or 44. So what ends up happening is you'll never get an answer back that goes higher than 90. As what you type in the parentheses gets closer and closer to 1, you'll get an answer that starts to get closer and closer and closer to 90. And if you put in exactly 1, you'll get exactly 90. Now you might think, well, what if you just go a little bigger than 1? Won't you get an answer that starts to get bigger than 90? You won't. If you try to type in something even just a little bigger than 1, you can't do it. And we'll talk more about why you can't go bigger than 1. But the idea is when you do inverse sine, you'll never get an answer that's bigger than 90, and you'll never get an answer that's smaller than negative 90. Now, all the ones I typed in so far, I didn't get any negatives. That's because I didn't do something like this. Negative 30. And as I get closer and closer to negative 1, like negative 0.8, that angle is going to start to get closer and closer to negative 90. All right. Michael, what is this? How would you say this number on the left?
Negative 90 degrees.
Negative 90 degrees. Okay, negative 90 degrees. That means whenever you do inverse trig, the answer that you get back is an angle. So all these numbers that you see on the screen, negative 30, negative 53, 89 point, whatever I had earlier, all those numbers were angles. That's the point of inverse trig. Inverse trig helps you to find an angle. That's what you use it for. Whether you use inverse sine, inverse cosine, or inverse tangent, that depends on the problem that they give you. But any inverse trig function is used to find an angle. So inverse sine always gives you answers between negative 90 and 90. Inverse cosine between 0 and 180. An inverse tangent between negative 90 and 90. Now, those are always the same, no matter what calculator you use. Always. This isn't what it has to be, but this is what everybody agrees that it will be. There are other ways you could do inverse trig. Instead of always giving an answer between negative 90 and 90, you could do it differently. But the problem with that would be is if you're going to do it one way, and then I'm going to do it a different way, we'd both be right, but we'd have different answers. Well, we don't want everybody to get different answers. Okay, when we do inverse trig, we all want to get the same answer. So this is what everybody agrees on when you do inverse trig, and that's how calculators are programmed, that's how computers are programmed. They're all set up to do inverse trig this way. Now, we're going to take a look at what happens if we didn't all agree on these. I'm going to show you an example right now. So let's see if we can kind of figure out where some of those ranges that I just gave you come from, like the negative 90 to 90, the 0 to 180. So I've got a table. On the left, I've got an angle. On the right, I'm going to put the sine of that angle. So let's do 30. Let's take just the regular sine of 30, and the answer is 1/2. So, if I did inverse sine of 0.5 and I hit enter, what do you think I'm going to get back on the screen? 30. It's going to reverse what I just did. Simple enough. Take the sine of 30, you get a half. Take the inverse sine of a half, you get 30. Take the sine of 65. Right? That's 0.906. Now, if I take the inverse sine of 0.906, what do you think I would get back or get pretty close to? 65. How come it might not be exactly 65?
Because you don't have all the exact, like 906307778.
Yeah, this decimal just goes on. Just keeps going. So I get back basically 65. Okay, but it's round. Right. If I take the sine of 90, that gives me 1. So if I were to type in inverse sine of 1, I get 90. So far, so good. Okay, any questions so far? So if you take the sine of what's on the left, you get what's on the right. If you take the inverse sine of what's on the right, you get what's on the left. Now let's take the sine of 150. 0.5. What's the problem now? What just happened? Well, how did I get this number on the right? What did I do? Oh, Sarah? I did the sine. I took the sine of the number on the left, and I got the number on the right. Now I want to go back. So if I wanted to go back, Ariel, what would I have to do with this number to go back to this number? Well, how did we, like, if you had this number, go back to that number, or that number and go back to that number? Yeah, do the inverse sine. So let's try inverse sine of a half and see what happens. Did I get back the answer that I started with? No. I got back 30. And that's because when you do inverse sine, the answer is always between negative 90 and 90. It'll never give you back 150. There is no way to ever go back to that number. And we could type in a bunch of them. I could type in sine of 390. That's also a half. But if I do inverse sine of a half, I'm not going to get 390 back. So the problem is there's a bunch of angles you can take the sine of and get an answer of a half. But when we do inverse sine of a half, we don't want to get a bunch of angles back as the answer. We want one answer back. Okay? Which answer we're going to get back is determined by that. Okay? We agree that when you do inverse sine, the answer you will get back is negative 90 to 90. Yes, 150 is another answer, but we're not going to use that one. Okay? 390 is another answer, but we're not going to use that one. Okay? Because then that would give us more than one answer to the same question. So we're going to agree to just give that answer. Okay? And there never will be more than one answer between negative 90 and 90. There'll always just be one. Same thing with cosine and same thing with tangent. So if you did, let me just do one cosine one. Let's say you did the cosine of 60. Let's stop doing half. Let's do something. Let's do the cosine of 30. Okay, so you get the decimal 0.866. Now, I could also do the cosine of 330. I get exactly the same thing. So if I do inverse cosine of 0.866, it's going to take the 0.866 and go back to what I started with. But which one do you think it's going to give me back? 30 or 330?
30.
30. Because we said cosine gives you an answer between 0 and 180. It's not that the 330 is wrong. It's right. But it's a different answer, and we only want one answer to the problem. So we just agree ahead of time, when you have multiple answers, pick this one. That's what this table tells you right here. It tells you which one to pick. So what we're basically doing is the opposite of what we did last week. So just to kind of summarize the kind of question you had last week and how it's going to be different from this week. Last week, I gave you an angle, right? Like 30 degrees or 45 degrees. Or if it wasn't a multiple of 30 or 45, you would have used a calculator. The point is, I gave you an angle, and you plugged it into a trig function. Which function? I told you which one to use on the test. Could have been tangent, could have been cotangent, secant, cosecant. But I gave you an angle, and I gave you something to plug it into. And then you told me the question mark. That's the answer to the problem. This week, I'm going to give you the question mark. I'm going to tell you basically the answer to the problem. What you're going to do is work backwards to tell me what angle would have given you that answer. And that's inverse trig. You're working backwards to figure out an angle. I'm not giving you the angle. You're going to tell me the angle. That's the difference. So you need to find the angle. You're not going to be given the angle. And where finding angles starts to come in later in the week is if I give you a triangle and I say, find the angle in the triangle. This is how you're going to end up doing it. You're going to use inverse trig. Okay? But you're not using inverse trig for every single problem. You're only using inverse trig if you need to do that. Find the angle. If you have a problem and it doesn't require you to find an angle, then you're not using what I'm teaching you at all right now. This is only used if you don't know an angle and you need to figure it out. All right, so now I'm just going to briefly describe when you can, when this table will help you. Because sometimes it'll help you, sometimes it won't. Obviously, I can't print a table with every single angle possible on it. I mean, every angle with every decimal you can imagine. This table will only help you if the angles are multiples of 30 and 45. So, don't start that yet. I just want to show you an example question. So that's a problem that we're going to try to solve. So we're doing inverse trig, which means we're trying to find what? If you're doing inverse trig, you're trying to figure out what? The angle. Trying to find an angle. So you don't know the angle. Well, the way I'm going to tell you to use this chart is if the angle is a multiple of 30 or 45. But you don't know the angle. So how do you know whether or not you should even be using this chart? Because you're not going to get the angle till you finish the problem. Well, the way you know whether to use this chart, even though you don't know the angle yet, is look at this. That's your argument. You're going to look for that number in the chart. So the kind of numbers you're going to see on this chart are numbers like this. You're going to see ones, negative ones, halves, root 3 over 2, root 2 over 2, root 3s, or negatives of anything I just said. If the argument, which is the thing right here, the thing that I just circled, looks like any of those in parentheses, then you know you can use this chart. If the argument looks something like, say, 0.721, well, 0.721 is not a number on this table. You're not going to see it. Those are the numbers you're going to see on this table. So if you get a number that's not in that list, you're not using this table. And at the very end, I'll show you how to type it in on a calculator if it's not in there. Very, very simple. Okay, everybody had that? All right. So now we'll practice some problems that use the table. All right. So evaluate. That means when you're done, you should have an angle as an answer because we're doing inverse trig. Be careful on the test if they say put your answer in degrees or put your answer in radians. That's going to change what you tell me. It's also going to change what mode you put your calculator in. Okay, when we get to that one. All right, so the way you're going to use this table, you're doing inverse sine. So first thing is you're going to look down the sine column. Forget about every other column there that's not sine. The next thing is you're going to go down the column and you're going to look for the number 1. You may find the number 1 in more than one spot. If you do, that means you just found multiple answers. It's not that the other answer is wrong, but we all agree, whether you really want to or not, you have to give me the answer between negative 90 and 90. So if you ever find more than one answer, use these rules to go by which one you tell me. Okay? All right. So if we go down the sine column till we find a 1, can anybody tell me what angle is in the row where you find a 1? Yep, Joanne?
90.
Yeah, 90. And if you keep looking, you don't see that number again. So you could put 90 if they wanted degrees. Now, what if they wanted an answer in radians? What would you put instead of 90? Yep.
Pi over 2.
Pi over 2. I'm not going to do every problem using both degrees and radians, but I'll start out doing a couple both ways, just so you can see. So that is the inverse sine of 1. Inverse sine of 1. The answer is 90 degrees. So you just figured out this question. The sine of what angle gives me an answer of 1? That's the question you just solved. You figured out what angle I would have to take the sine of, and the answer would come out to 1. Okay? And we can check it by typing in what you guys got. Type in the sine of 90, and you get 1, which means the inverse sine of 1 is 90. All right, let's try this one. Inverse sine of negative 1. Okay, so now you just go down the sine column until you find negative 1. And then read back the angle that's in that row.
270.
Negative 90, yes. Why would you say negative 90 and not 270? I mean, 270 is correct. Why aren't we going to write that one down? Yeah.
This is not in between negative 90 and 90.
Right. We said we're going to go with negative 90 to 90. That's how every textbook does it. That's how our calculators are programmed to do it. And that's the way we're doing it. Right. It's not that there aren't other answers, but we all have to agree on which one. Okay. So we're going to go negative 90. Okay. Or negative pi over 2 if you wanted to do it that way. Okay, let's try this one. Inverse sine of 1/2. So just for people that are watching the video, that's the chart we're looking at. We're going to go down the sine column till we find a 1/2. And then we're going to read off the angle. Now, this one you're going to find 1/2 in 2 different rows. Anybody tell me what's the first row that you see 1/2 in the sine column? Yeah, go ahead.
30.
Yep, so Kyle said we've got it in the 30 row. So we got that. What's the other row that we see it in? Yep, Sarah. 150. So really now you've got a choice of 4 things you could tell me. 30, negative 330, 150, negative 210. There's only one answer there that is the one we all agreed we're going to go with. What's the correct answer? Yep, go.
30.
30. No other answer there is between negative 90 and 90. And no matter what number you ever pick, you will never have more than one choice between negative 90 and 90 for inverse sine. All right, let's try this one. Inverse sine of root 2 over 2. So as you go down the sine column, if you find the answer that's between negative 90 and 90, you can stop. You can keep looking for the second answer if you want, but it's not going to work. So how about Joe? Do you see what angle is in the row that has root 2 over 2? Yep, 45 right here. 45 degrees. And again, you might say, well, why not the negative 315? We already talked about that. Why not the other one, root 2 over 2 that's down here? Same reason. It's got to be between negative 90 and 90. All right, and let's try this one. Inverse sine of negative root 3 over 2.
Negative 60.
Yep, negative 60. That's another one. You're going to see it in multiple rows, but I want the one between negative 90 and 90. Now, Hendrik, what if they wanted that in radians? What would you put?
Negative pi over 3.
Yep, negative pi over 3. Okay, so very important on the test, you pay attention to what they're asking for, degrees or radians. They could say it in the directions, which way they want it, or if it's multiple choice, look at the choices. If the choices have the little circle above them, then they're obviously degrees. If the choices they give you don't have the circle, then they're in radians. All right. So let's take a look at the next one, inverse cosine. Yeah, we're not going to go through as many this time, just a couple. But now you get to kind of switch gears a little bit. You're not negative 90 to 90 anymore. If you try negative 90 to 90 with this, it won't work. What are we going to be between now for inverse cosine? The answer is always between what?
180 and negative 180.
I agree on the 180. That's the highest.
Yeah, 0 to 1.
0 to 180. They're all 180 apart. Like negative 90 to 90, that's 180. 0 to 180 is 180. Right? So that's one mistake you could make. You don't have the right interval you're looking in. And the other mistake you could make is you're in the wrong column. So now focus on the cosine column. Okay. So what would be the inverse cosine of 0? 90. Yep. Go down the cosine column, right there. If you keep looking, you're going to find 0 again. And this is where you'd get messed up if you're using the negative 90 to 90. Because you'd say, well, wait a minute, that answer is 90, that answer is negative 90. He said there would only be one to pick from if you use the right numbers. This is 0 to 180. 270 and negative 90? Nope. Negative 270? Nope. 90. Yep. Let's try inverse cosine of negative 1/2. You can do it in degrees or radians. Yep. That's 120. Yep. And don't forget what you're doing here. You just answered this question. The cosine of what angle would come out to -1/2? You just solved for the question mark. You figured out what angle you could take the cosine of. 120. And the answer you would get is -1/2. Okay, so you're solving for an angle. Right, and now let's try one more. Inverse cosine of -√2/2. Yep.
135.
That is 135 right there. Okay, if you keep looking, you will find it again in the 225 row, but that answer is not going to help us. Okay. Any questions on that? All right, so the last one we're going to look at is inverse tangent. What are we supposed to be between for inverse tangent? So is that the same as inverse sine? Let's go back. Take a look at it. So look carefully at inverse sine and inverse tangent. The numbers are -90 to 90. So is it exactly the same as inverse sine? No, what's different?
Sine can be equal to.
Right. With inverse sine, you can actually equal 90 and -90. You can't equal it with inverse tangent. Look at your chart. What happens if you try to equal 90 in the tangent column? Undefined. You can't do that. Can't do that. The reason why you can't do it, we saw last week. Tangent was y divided by x. Y divided by x. What's the coordinate on the unit circle when you're at 90? It's 0, 1. 0 is which letter? And the 1 is the... So if x is 0, can you plug 0 into a fraction and then divide by it? You can't divide by 0. That's why the tangent of 90 is undefined. And it's also the same reason why 270 would be undefined. You still have a 0 in the x spot. So if you look at your table, and you look at 270, and you look at 90, they're both undefined. And 270 is the same as -90. So that's why it will never equal -90 or 90. All right, so let's just try. Let's try 2 of those. I'm gonna give you guys maybe like 30 seconds and just see if you can get both of those on your own. All right, so the last 2 we're looking at inverse tangent. And we already said we're going to be between -90 and 90. So how about Edmo? What did you get for inverse tangent of square root of 3? Yep, square root of 3. It's in the column. It's in the row with 60 degrees. Now, why didn't you say -300? Because that's also equivalent to 60 degrees. Right, it's got to be between -90 and 90. Right, and the last one, inverse tangent of -√3/3. Let's take a look. So you said negative, which one? -30? -30. -√3/3. Yep. Right there. -30. Okay. Any questions on that? All right. So the chart does a lot of good stuff, but it only helps you with angles that are multiples of 30 and 45. So if you can't find the answer in the table, then we're going to use a calculator. So on most calculators, like the ones that I have, the graphic one that I use on the board a lot, to get to an inverse trig function, you have to press second. Now, if you have a Casio calculator, they seem to do things really different sometimes, so it might not be the same. Okay, so if I wanted to type in inverse sine of 0.65, okay, I'm going to do this problem two different ways. First way I'm going to do it, my calculator is set up for degrees. Because remember, when you do inverse trig and you hit enter, that number that you get on the screen is an angle. Angles have to have some kind of label. Radians or degrees is the only two that we use in this class. All right, so inverse sine, and the way I did it is I press second, and I press the sine button. Okay. If you're using one of my calculators, it's exactly the same thing. If you're using one of yours and you can't figure it out, just call me over after because you'll have time to start the homework, and I'll help you. Okay, so second, sine, 0.65, except I hit an extra button. 0.65. And the answer is 40.54. So if you got 40.54 degrees, you did it right. Now you have to put that degree symbol, because if you leave that off, what would you be telling me the answer is? You're telling me radians. Right? If you want radians, that's a totally different answer. Mode, put it in radians, type in what you just typed again, and in radians, that's 0.71. If we're going to go to 2 decimal places. Both of these are approximate. Either answer is correct. Now, let's say it was a multiple choice question and I gave you these choices. I'm just going to give you 3. 0.65, 40.54, 0.71. Which answer there is correct? C. If you're thinking there's 2 correct answers, you didn't look close. This answer here and this answer here are totally different. They're not the same thing at all. That's 40.54 radians. So the correct answer, the way I have everything listed, is C. Now, what if I did this? What's the correct answer now? Now the correct answer is B. Right? So if you see both numbers listed, check the units. One's degrees and one's radians. Right, so just be careful of that. Okay, let's do inverse cosine and negative 0.24, and let's just do it in degrees. Now, some people get confused and they're like, well, what's that number? Is that degrees or radians? That number is nothing. That's not an angle at all. That's just a number. There's no label to it. What's going to have a label is the answer that we write down. So, mode, degrees, and second, inverse cosine, negative 0.24. And what'd you get when you typed that one in? Yeah.
103.89.
Let's check it. Perfect. 103.89. Now, you could try to use the table for that one, but you're not going to find negative 0.24 in the table. That's why we didn't use it. Okay, so once you start using the table, you just got to get used to what kind of numbers you can look for and which ones you can't. Negative 0.24, you can't. It's not it. All right. Now, I want to look at this for a second, and I'm going to do the same thing on the next one, because then we're going to get to a problem after the next one that you're going to get stuck on if you don't think of it this way. So, another way to think of this problem is you just figured out the answer to this. The cosine of what angle, which you know the angle now, but the cosine of what angle would come out to negative 0.24. So you solved for that angle and it was 103.89. Okay. Let's try this one. Can someone just tell me how to do what I just did on the last problem, kind of rewriting this? What's another way to think of what they're asking you for here?
The opposite. The opposite.
So if you were going to put after that arrow, kind of like I just put after that arrow, what would you put?
This question mark.
So the tangent of what angle? Yep.
34
Anything before that?
equals.
Equals. Okay, that's what you're trying to figure out. The tangent of what angle would give you 34.3? And this is how you figure it out. Take the inverse tangent of 34.3. Okay. Anybody have what that one comes out to? Because I don't. Yeah. 88.33. Thank you. Thanks. So that's the angle. So you could check it by taking the tangent of 88.33, and it should come out to 34.3. But rounded. Might be like 0.29 or something like that. Okay. Questions on that one? All right, so now let's take a look at this one. The inverse secant of 1.45. What do you think the problem is with this one? It's still just an inverse trig problem, but look at your calculator. Yeah.
There's no button.
There's no button for that. There is no button for inverse secant. Just like when you did regular secant on the calculator, there was no button for it. So we're going to have to turn that into a problem that we have a button for. So the first step is I'm going to think of it a little differently. I'm going to think of it like this. I'm just going to put an arrow. Arrow just means I'm kind of transforming the question to think about it in a different way. It's still the same question. But the secant of what angle is equal to 1.45? That's still not something you can plug into the calculator because you still have secant. But there's a function we learned about last week that's connected to secant. And when we usually wrote the 3 on the right, the 3 on the left, and then we put the 3 on the right. Which trig function was always across from secant?
Cosine.
Cosine. And what's the connection between secant and cosine? Like if you've got the cosine, what do you do with it to get the secant? You flip it. So if you flip both sides of that equation, which you're allowed to do, as long as you do the same thing on both sides of an equation, it's still true. Like if you add 1 to both sides, that's fine. Multiply both sides by 12, that's fine. If you flip both sides, that's fine. If you flip the secant, you now have the cosine. So I'm just going to put what we did from here to here. We flipped. And if you flip 1.45, you have that. All right. So now the last step is to translate that into something that we can type back into the calculator. So now I want to put something back right here. So I started with secant at 1.45. I reworded it so I could think about it a little differently. The secant of what angle is 1.45. And then I flipped both sides. When you flip secant, you get cosine. When you flip 1.45, you get 1 over 1.45. So now using what I just underlined in blue, what do you think I can put in this box to type into the calculator? Yeah.
Inverse cosine. 1/1.45.
Yes. It's the inverse cosine of 1 over 1.45. This problem that you started with originally and this problem below, it's exactly the same question. The difference is the one below you have a button for and you can type it in. So the trick, all you have to do is take this number and flip it. Take this trig function and change it to the one that it's connected to when you flip it. So change the trig function, change that number. And that's the pattern every time. So let's just type it in. Inverse cosine of 1 divided by 1.45. 46.40. That's the answer. And if we had an inverse secant button, we wouldn't have to go through any of that. But we don't. So that's what we do.
Shouldn't it be like in radian?
It depends. Was my calculator? No, my calculator was in degrees. That answer would be in radians if I did it like this. Radians. Second, enter. And now it would be 0.81 if you did it in radians. Any question on that? And you don't have to worry about getting an answer between 0 and 180. Calculator will always give you an answer between 0 and 180. The only time you have to worry about it is when you use the chart, because the chart has multiple answers on it. Okay. All right, let's try this one. Okay, first thing, do we have a button for inverse cosecant? No. So what trig function can we change it to? Sine or inverse sine?
Inverse.
Inverse sine, yep. So now you changed it to a trig function you have a button for, but now you also have to change 2.6. What does 2.6 turn into? 1 over 2.6. So when you're doing inverse trig like this, it still has to do with flipping something, just like last week, but it's a little different. You're flipping what's in the parentheses. So let's try that. Inverse sine, 1 over 2.6. Now I'm going to change my mode back to degrees. And if you ever get out of this, you can hit enter. And you get 22.62. So that's what you should get. So not that hard to type it in, even though you don't have a button for it. You just have to know how to do it. And last one. How would I type in to get the answer for the inverse cotangent of 0.35? Well, step one, you could look at the table. That's not going to help you. So now step two, we got to go to the calculator. Yep. Type in inverse tangent of 1 over 0.35 and over 0.35, you get 70.71. There is no set rounding to this. I usually go with 2 decimal places. If in the test or homework they want you to do something else, it will be in the directions. Definitely in the directions on the test. If it's not in the directions in the homework, just go with 2. Okay. Any questions on that? Okay, so that's the first part of inverse trig. Okay, so homework tonight. Tonight it's in the book. Thursday is the only day we're going to do a worksheet, but that's going to be in class. So 13 to 17, 19, 20, 22 to 31, and 33, and that's all. Okay, the first part you can use the table for. The second part of the homework, I think the 22 to 31, you need a calculator. So if you don't have a calculator at home that can do inverse trig, then you might want to do the 22 to 31 now, well, you have a calculator that can help you. If your calculator, you're not sure which buttons to press and you want me to come help you, just call me over and I'll come take a look.